Alrighty, in today's lesson, we're going to be talking about 6.4, which is logarithmic properties and models, which is basically just properties and word problems of logarithms. So again, this will be lesson 6.4, logarithmic properties and models. So a couple highlights in the section. It's reminding you what continuously compound interest formula is, because now we're going to be able to solve it. So continuously compounded interest. All right, and again, that was A equals P times E raised to the RT, or also known as APERT. So remember that, and we'll learn how to solve for different variables of this type of equation. Then we have properties of logarithms. Um, and they are the product rule, which basically just states if I have a logarithm where I am multiplying two things inside, I can expand it by writing it as log of the same base of x plus the log base a of y. So if I'm multiplying two things, I can expand it and make it two different addition problems. This might make it easier to solve, and vice versa. If I want to condense it and I'm adding two like bases, I can make it become one logarithm. We also have the quotient rule, which is basically just stating it's if I have two things being divided inside of a logarithm, I can expand it as a subtraction problem, where the top will always be subtracted from the bottom. And vice versa, if I'm subtracting two logs of the same base, I can rewrite it as, or condense it as one single logarithm. The last rule is the power rule. And that's just stating if I have something inside raised to some random power, I can rewrite it as the power of the leading coefficient. And vice versa, if it's the leading coefficient, I can make it a power when trying to condense it as well. There's also this thing called change of base form. And this is used to sometimes make it easier to solve things. Let's say I have log b of x. Let's say I want to evaluate this without a calculator or come close to it. I can rewrite this as log base 10 of x over log base 10 of b. And that ratio there will give me the same answer to the actual logarithm itself. Then there are three distinctive models or word problem equations. Um, there is the pH scale, which is the negative logarithm of the concentration of whatever the acid is, so H3O plus. Usually will give you that amount, and then you can just plug it in. We also have a formula for the Richter scale. We want to know the intensity of an earthquake. That is written as R equals the logarithm of the intensity of the earthquake you're investigating versus a initial intensity of something else. So this would be like, if I know that this is 4 times greater than this one, then this will just become 4 times I to the 0, and then I to the 0, or the initial intensity will be what canceled, and you're just looking at what's being times that amount. But we'll do some problems like that. They look scary, but they are not that bad. And then we have the decibel scale, which is like sound, which is actually 10 log, again, of the intensity divided by the initial intensity. So these are the three type of equations. This is actually a negative, not just a dash here. But these are the three equations that you'll be used in the homework. I do believe they supply it every time, but just to make sure that we all have it. All right, let's jump into the examples in the book. So let's look at number 1 first. This says log base 5 of 125x cubed. And what they want us to do first, it says use the properties of logarithms to expand the following expressions as much as possible and simplify any numerical expressions that can be evaluated without a calculator. So this is how I like to teach it. I'll figure out everything that's being done inside. I have a 125 times a x to the third. All right. So since I have two things and I'm expanding, I'm going to write this log 2 times. So that's going to be log base 5, log base 5. All right. So there's 2 things, so I write log 2 times. If there was 4 things, I would write log 4 times with whatever that base is. So I'm going to write the first thing I see, which in this case is 125, times when expanding means to add, and then I have x to the third. Now, to condense or expand this even more and also to simplify at the same time, when you have values, you actually need to solve it if it comes out as a perfect number without a calculator. So remember, this right here is basically saying 5 to what power will give me 125. And so you can do 5 times 5, which is 25, times 5 again, which does give me 125. So log base 5 of 125 is 3. So this goes back from the previous lesson on simplifying this by getting the answer. Again, you can set this equal to y and do some side work and figure out, all right, 5 to what power gives me 125 using the log rule from the previous section and see that that's going to be 3. If it doesn't come out as a nice pretty number, then we leave it as is. Over here, anything that has an exponent when we are expanding now needs to become a coefficient. So this becomes 3 plus 3 log base 5 of x. So this is the expanded form that's also simplified. All right, let's do another one. So let's look at number 2. This is the natural log of x squared y divided by 3. Once again, when I look at this, I'm going to go, all right, there's one thing. I can barely see the difference there. Let's try this one. So I have one thing times another thing divided by another thing. So that means there's 3 different things going on here. So I'm going to write natural log 3 times. All right. Now I'm going to plug in each thing. So I have an x squared. Times means to add. Natural log of y. Division means to subtract. Natural log of 3. Right? If you were to have multiple things here, you would keep it minus. So everything that's on top will get a plus, everything on bottom will get a minus. At this point, we just keep this working. So I will then take any exponent, make it a coefficient, simplify if I can, but remember natural log is like an e, and e to anything is not going to give me a whole number. So I can just leave this one as is. So it's going to be 2 natural log of x plus the natural log of y minus the natural log of 3. There you go. There's your expanded form. All right. You'll also be required to condense. So let's look at number 25. Again, you're condensing it down to one singular logarithm. So this is going to be log 3 plus natural log p minus 2 natural log q. When you are condensing to a single logarithm, you're only going to write that logarithm one time and then do the work. All right, so I got a 3. Plus means to multiply. The next one's a p. Minus means to divide. Any coefficient becomes an exponent, so then this becomes q squared. So if you wanted to clean that up a little bit, you could also write it as 3p q squared. But I think they'll accept this too. This is perfectly fine, just without the dot. All right, so that's it. So when you're condensing down, your goal is to get it to one logarithm. All right, let's look at number 43. Number 43 says use the properties of logarithms to write each of the following as a single term that does not contain a logarithm. So we're going to use all the rules from the previous two sections of logarithms. So if I have 5 raised to the 2 log of 5x, so we're going to use everything we've learned up to this point. Coefficients become exponents. So this now becomes 5 log base 5 of x squared. We've learned that if this base is the same as this base, then the answer will be whatever this is. So in this case, x squared is your final answer. So this is using all the rules from 6.3 and the properties that we just learned in 6.4 to get an answer with no logs in it. All right, so be able to do that, and then you need to be able to evaluate the function. All right, when evaluating these functions, personally, you're supposed to use the change of base formula. And in previous times I've taught this face to face, I would always have students just rewrite it using the change of base formula. So that would be log 17 over log 4. But they want you to use to evaluate. So what happens is if you don't do this and you just do this, you get the same answer. So let me get to a point where I can pull up the calculator real quick. All right, so in our calculator, what I was talking about when we go to regular calculator, if I use the change of base formula, I can do control divide. And then the log button is located right here in blue above the 1, or in a different color above the 1, or next to the 1 above the 10 to the power of x. All you gotta do is hit control and then that button to make the log appear. You don't necessarily have to type anything there. You can either type a 10 or don't type anything. If you don't type anything, it'll still treat it as a 10. And then I would put my 17. I'll do control 10 to the power. Again, I'm not going to type anything. And you get 4. And it gives you an answer. So again, see how they put in the tens for you, even if you didn't put it in there. Now, check this out. If I just straight up just do control log and I just type in what it asked me to evaluate and I get 4 and 17, you get the same answer. So when the questions is asking you to evaluate, technically you can just do this. But if it ever asks you rewrite it using a change of base formula, then this would be the answer. So just make sure you understand the change of base formula, but to evaluate, it's just as easy to type it in. All right. So again, in this situation, regardless of which way you go about doing it, you get 2 point, and it says, see, it doesn't say, but in the homework, it rounds it to the hundredths place. So this would be 2.04. And if we did this a few more times, let's look at number 56. So 2 log 1/3 raised to the 5th. Again, I would want to take this as my exponent. So this technically what this does is becomes log 1/3 5 squared, which then just becomes log of 5 squared over log of 1/3. And then technically you can see that that 2 then would just be applied to the top if you had to rewrite this using the change of base formula. Or again, it's just asking you to evaluate, so I can go straight into this. So once again, I can plug it in as 2 log 1 divided by 3 and then a 5. And that's what I get. But you'll get the same answer regardless of which one you do. So you would want to do this method if it specifically just tells you to rewrite it using the change of base formula versus just calculating it. But this will be negative 2.93. Let's do another one. So number 57, log base 9 of 8 can be rewritten as log of 8 over log of 9. Again, to express the evaluation, you just plug it into the calculator. So I'm not going to switch back. I think at this point you understand. If not, I don't mind doing another video on it. But in this case, we would get 0.95. All right, let's just do one more to make sure. You get log base 2 of 0.01 can be written as log of 0.01 divided by log of 2. So I'm just going to make sure we do fully understand how to type this in. So you can kind of see I've already written the log 9 of 8, and that's how I got the 0.95. So if I do this again, this is just control log 2 and then 0.01, and it gives me negative 6.64. So in this case, I get negative 6.64. All right, so hopefully that's enough for you to understand how to plug it in and to evaluate. The last part of today's lesson is those models, which are the word problems. So let's jump right into that. Let's look at number 94. It says a certain brand of tomato juice has a H3O plus concentration of the 6.3 times 10 to the negative fifth moles liters. What is the pH of the brand? Well, in the book, again, it gives you that pH of negative log of whatever the concentration of this is. So what we're going to do is just do negative log of 6.31 times 10 to the negative fifth power. And we do that, all we have to do is just plug this into the calculator. So we'll come over here. Well, hold on. Before I do that, I mean, you could simplify this in the approaches that we've done, but again, this goes back to that change of base formula idea. It doesn't help us get a cleaner answer, but we'll do it anyways. So this is going to be negative log, all negative. But since I'm multiplying, I can expand it by making it a plus. And then these guys become a coefficient. Well, technically, -5 log 10. And then this, since these two are technically the same, because that's an imaginary base of 10 and 10, this ends up just being 1. And then 5 times 1 is just 5. So we get negative log of 6.31 minus 5. But again, we'd still have to type it into the calculator to figure out what log of 6.31 is. So that's what my argument is that, okay, that's cool. If it tells us to rewrite it in a simplified expand form, bam, we can do that. But if we're just asked to evaluate it, we could go straight into multiplying to this thing. So let me show you both. So if I plug in what I just calculated, which was a negative parentheses log, it was base 10, right? So it'd be log 6.31 and then minus 5. I get this as an answer. Or I could have even just typed in negative log of, I think it was just base 10, but it was 6.31 times 10 raised to the negative 5. And notice you get the same answer. So if it's asking you to rewrite it, then that's the approach you need to go. But if it's just asking you to evaluate it, you still have to use the calculator. So might as well just start from the beginning. So again, this gives us, again, we're rounding to, just says the tenths place. So 4.2 would be the pH of this tomato juice. All right, let's do another one. Let's look at number 96. This one says, what is the concentration of H3O plus in lemon juice with a pH of 2.1? So again, here's the formula. So pH is equal to negative log of H3O plus. This time we're trying to calculate this. They gave us the pH. It was 2.1. I'm actually going to change this to an X just so it's easier to solve for. First thing I'm going to do is divide by -1 to get rid of that -1. So now I get negative 2.1 equals log of X. And then using the log rule from the previous section, which again was log base B of X equals Y, can be rewritten as base Y equals X. I'm going to do that. So my base here is 10. So that's going to be a 10 raised to the negative 2.1 equals my X value. Now I have something that's way easier to type into the calculator. You could try to do that. If this was a whole number, we could easily do it. 2.1, a decimal though is not something that we just kind of know. But here we go. So I come over here and I'll type it in, which was 10 raised to the negative, nope, was it negative? It was negative 2.1. And there's the answer there. So if you can do that in your head, that's awesome news. But I cannot. So there we go. So calculator does get utilized, but we do have to get it to a point where we can actually play it into a calculator. On this one, the way this would be written, so I'm gonna write the whole thing out so you can kind of see. You have to write it in scientific notation. So if you're unaware of how to do that, move the decimal over until you get a number that's between 1 and 10. 7 is a number, 7 with a decimal is a number between 1 and 10. So I'm going to write 7.943 times 10, and you just write how many times did you go over. So that's 1, 2, 3. So because I went to the right, because it's a decimal, this is going to be a -3. So you can think of it like this direction or this direction, but this -3 will tell me to move this decimal to the left. So if I'm writing it like this, if I have a number less than 1, I need it to be negative. If it's a number greater than 1, it would end up being positive. So that's the result there. So that is your concentration there. And I believe they even went to just the hundredths place there. So I don't even think you need the 3. And then they do add that notation of moles per liter. All right, let's do another one. So let's look at number 97. 97 is now talking about the Richter scale. So it says an earthquake in Chile in 2019 measured 6.7. So that would be the Richter scale intensity. What was the intensity relative to a level 0 earthquake of this event? So level 0 earthquake, what it becomes is hold on, what is the Richter scale? All right, so it's R equals log of the intensity over I0. Sorry, this is the Richter scale. That's your R. And we're trying to calculate what the intensity of this event is. So it's it's made up of whatever the intensity of that value is times the initial intensity that you're looking at. So really, when you're looking at this, it's really just always going to kind of end up being this, but this time the Richter scale is 6.7. So using this information, I can use the log rule. So remember there's an imaginary 10 there, so this becomes 10 to the power of 6.7 would be my intensity level. So let's check it out. So again, this is going to be 10 raised to the 6.7. And there is my intensity level. So I get 5. Let's say again, it doesn't ever say, but in the homework, it's rounding. Oh, it doesn't put it in scientific notation. It just writes the entire number out. All right, so let's rewrite this. When you see this in a calculator, this means 5.01187 times 10 to the 6th power. Since it's positive, I'll move that decimal to the right 6 times. So that's 1, 2, 3, 4, 5, 6. Any missing numbers will get a 0. So it's 5011870. And so that is the intensity. It was 5 million and something times the intensity of that event, stronger. So 6.7. So that's seems like a ridiculous number of intensity, but that's how they measure it. All right, let's look at number 98. It says, how much stronger was the 2001 Gujarat earthquake? So that was a 6.9 on the Richter scale. Then the 2019 earthquake described in 1927. So here we go. So we have a ratio here. And he wants to know the intensity level of both. So again, our equation is R equals the logarithm of the intensity over the initial intensity. So it says how much stronger was this? So I would assume hmm. All right, my assumption, okay, so if we have home, we're trying to look how much stronger. So we're trying to figure out this ratio, right? If I know the Richter scale is 6.9, and so let's do that. So we'll calculate what this intensity is and then divide the two up. So this becomes 10 to the 6.9 equals X. And if I take the previous work and I want to know how many times it is, I can take this answer that I just got, divide it by the answer that I just got in the previous one, which was 10 to the 6.7 as such. And then if you have like bases, you can actually subtract. So this is going to be 10 raised to the 0.2. So whatever that answer is will be it. So we had to calculate what the intensity is for the Gujarat earthquake, which was 10 to 6.9. But without having to do too much of those big old numbers, the ratio would be the Gujarat one divided by the Chile one. And then because they're like bases, we can just subtract the exponent. So my intensity factor on how much greater this Gujarat earthquake was would be a 10 to raise to the 10.2, which would give you 10 raised to the 0.2, and it gives you a 1.58, and I believe in the homework, it's going to round to the 10th place. So this gives us a 1.6 times stronger. All right, so it doesn't seem like much, but it was still a little bit more intense than the chili one. All right, let's look at number 99, where this one talks about the decibels. So it says a construction worker operating a jackhammer would experience noise with an intensity of 20 watts. So let's get the equation first. That's 10 times log of intensity over the initial intensity. All right, so we got a jackhammer will experience noise of 20 watts per meter squared. If it weren't for ear protections, given that the I0 is 10 to the negative 12, what is the decibel level for such noise? So this would be 10 times log. The I would be the jackhammer, so that's 20, divided by the I0, which is given to you, which is 10 to the negative 12. And then there you go. So you can take this, plug it straight into the calculator, which is my recommendation, or you can just expand it. I don't think it's going to give us a straight up answer, but for sake of experience, this would be 20 minus log 10 to the negative 12. Bring this up to the front. I now get 10 times log of 20 plus 12 log of 10, which we now know is 1. So I get 10 log, if I distribute, 10 log 20 plus 120. The issue is I don't know what log 20 is. So 10 to what power would give me 20? There isn't one. So again, I would still have to plug this into the calculator. And when that happens, just start off with the beginning, in my opinion. Again, just it's mine. You can take it as you want. So again, that's 10 times control log. Where's the formula? So again, it's a 10 as the base. Control divide to make it a fraction. Originally it was 20 watts. Divide it by 10 to the negative 12, and I get 133.01. If you wanted to plug the other one, again, that'd be 10 log 20 plus 120. And you see that you get the same thing. So we know we're expanding correctly, and we get the same conclusion regardless. So again, the decibel levels here would be 133. They just round to, I guess, the tenths place there. Decibels. Right. Let's do one more of these, and then we'll talk about regression line, and then that will be the conclusion of this one. So looking at number 100, it says a microphone picks up the sound of a thunderclap and measures its decimal level as 105. So again, our decimal level is 10 times log of the intensity. So we are given the decimal level of 105. And it says, okay, so a microphone picks up the sound of a thunderclap and measures the decibel level at 105, given that the I0 initial intensity is 10 to the negative 12. With what sound intensity did the thunderclap reach the microphone? So that's the value I'm calculating. So this one, we're going to have to do some work. Can't just type it in. So we'll divide by 10 here. Hopefully you see that that says 10.5. Just move the decimal over. And then this will give you log of I over 10 to the negative 12. Using the log rule, this gives me 10 raised to the 10.5 equals I divided by 10 to the negative 12. Multiply both sides. I then get this times this, so you would add. So that's going to be 10 to the negative 1.5. Again, if it wasn't for the decimal, I could probably figure it out, but we're going to go now to the calculator. And so that's going to be 10. Sure, I'm sharing. Okay. Get 10 raised. There we go. Negative 1.5. And we get 0.31. So here we go. All right, so in this case, again, they round to the hundredths place, so this would be 0.03 was the intensity, and I believe the measurement is watts per meter squared, which I found in the homework. It usually gives you the units. I remember being a student and we used to get counted off for not having units. So be thankful for that. All right, last question I want to look at is number 104. And when you're given a question like this, it says the menu developers for a chain of coffee shops have conducted experiments to see how long customers take to make a drink choice based on the number of drinks on the menu, normalizing so that the average time needed to make a choice given just two drinks is a one-time unit. The average times needed to make a choice given in drinks on the menu are shown in the table below. So basically, gives you a table. If there's between 2 to 7 choices, it tells you how long it takes. 2 choices, it takes them a minute. Up to 7 choices, it takes them 2.3 minutes to make a decision. But it wants you to find the best fit line here. So let's go into our calculator. And this is just like quadratics and linear functions of exponentials. Sure, guys. There we go. All right, so what we're doing here is just like before, you'll go to this list in spreadsheets. You'll type in your X, you'll type in your Y, and then you'll type in the table. So that's 2, 3, 4, 5, 6, 7. And then we get 1, 1.4, 1.7, 2, 2.2, and 2.3. And we go home, go to data and spreadsheets, change this to your x-axis, change this to your y-axis, and then we just go to menu. We want to analyze. We want to go to regression, and now we're talking about logarithms, so we want to go to a logarithmic. It gives you an equation, and then there's your answer. All right, so jumping back over here, with all that data, you would get, again, this is T of n, because you have your X and Y. So your T is the function's name. That's the number of times or the amount of time it takes for n choices. So then this would then be, and does it say what to round to? It does. In the homework, it's going to tell you to round to the hundreds. So it's going to be 0.241 plus 1.074 natural log of X. Or I guess in this case, n. Right? And then there's your equation, and then that's all you would have to do. If there's any questions, feel free to reach out, and I'll make another video or help you out wherever you're at. Until the next video.